Hello friends, today's question. Column 1 describes some situation in which a small object moves. Column 2 describes some characteristics of this motion. Match the situations in column 1 with the characteristics in column 2. So we have these four, you can say, situations, and we have these four motions, characteristics rather. Okay. And these characteristics are mainly related with SHM, direction, kinetic energy, and the last one is also with direction. Okay, so we are going to take these motions one by one and try to identify which of these characteristics are matched with respective motions. So let's take the option A in column 1. So option A states that the object moves on x-axis under a conservative force in such way that its speed and position satisfy the equation V is equal to C1 C2 minus x square, where C1 C2 are the positive constants. Okay. So we are given that the equation V is given as C1 square root of C2 and minus x square, where C1 C2 are the positive constants. So we can just write this equation as V will be equal to square root of C1 square C2 minus C1 square and x square. And we also know that the equation in case of SHM, there is a relationship between the energy and the position of the particle. Okay. So we can write that in SHM, the energy is conserved and relation between velocity and position is given by, and that relation is V is equal to square root of 2 divided by m, and this is multiplied by E minus U of x. Okay. In this, the E is the total energy and U of x is the, you can say, potential energy. So we can say that E is the total energy and U of x is the potential energy, and which is given as half k x square. Therefore, if we substitute this value, we can write that, or we can make 1:1 comparison. So let me open this. So this becomes 2 upon m E minus 2 upon m, and this is our ux. So if we make 1:1 comparison, we can say that our C1 square C2 will be equal to 2m multiplied by E, and C1 square x square will be equal to half k x square. So from this we can say that our C1 square is equal to half k and if you substitute this value here, we get that C2 will be equal to twice 4 times mk multiplied by E. So this is the value of C2, or C1 we can also write in this way, square root of k by 2. So we got the value of C1 by C2. So indirectly we can say that the given equation, this equation, that velocity equation, describes the SHM, where C2 is in the form of the energy, total energy rather, and C1 is dependent upon the spring constant. So therefore we can say that the equation V is equal to, it is given as C1 square root of C2 minus x square describes an SHM. Describes an SHM. Okay. So therefore, for A, option number P is the correct option. So we can say that for A, option P is the matching one. Now we take the B part, which states that the object moves on the x-axis in such a way that its velocity and its displacement from the origin satisfy the equation V is equal to minus kx, where k is a positive constant. So let us option B. So in option B, the equation that is given is V is equal to minus of kx, and it describes the linear relationship between the velocity and the displacement x. This describes the linear relation between the velocity and displacement from the origin. And this also makes sure, or tells us rather, that the velocity is always directed towards the origin. Velocity is always directed towards the origin. So you can say that the object does not change the direction. Okay, it is always directed towards the origin. So there is no change of direction. The velocity is always directed towards the origin. So we can say the object is always moving towards the origin, therefore no change in direction. So therefore it is no change in direction. So we can say for B, option number Q is correct one, because it says that there is no change in direction. So you can say it is our Q. Now let us find out what happens to the kinetic energy. Next part is about the kinetic energy. What happens to kinetic energy? So kinetic energy is governed by the equation kinetic energy is equal to half mv square, and substituting value of v, we get half m, and this is our minus k x square, which becomes half m k square and x square. So it means if x is going to decrease, the kinetic energy is also going to decrease. So which implies that as x decreases, kinetic energy also decreases. So with respect to energy, we can say for B, option R is also one of the correct option, because he said that kinetic energy is going to decrease. So we have for B, option R is also correct option. So option B is going to have two options correct, Q as well as R. Now let us check for the option C. And option C is given that the object is attached to one end of the massless spring of a given spring constant. The other end of the spring is attached to the ceiling of elevator. Initially everything is at rest. The elevator starts going upward with a constant acceleration a. The motion of the object is observed from the elevator during the period it maintained this acceleration. Once again, we are going to find out what is going to happen, whether it is SHM or whether it is, you can say, what about its direction and everything. So as it says that the object is undergoing SHM and the elevator is accelerating upward with the acceleration of a. Okay. So it says that the object is undergoing SHM, but the elevator is accelerating upward with constant acceleration a. With constant acceleration a, therefore we can say the effective force that will be acting on the object will be equal to m multiplied by g plus a. Therefore effective force acting on the object is equal to m a plus g. So we can say that the restoring force will cause the oscillation about the equilibrium, and the only difference will be that the equilibrium will be the shifted equilibrium. Okay. So therefore we can say the restoring force will cause the oscillations about the equilibrium point but the equilibrium point is shifted. Point is shifted. So it means for C it is going to execute a SHM. So for C, P is the correct option. You can say for C we have P as a correct option, and let us find out about the option D. And option D states that the object is projected from the Earth's surface in vertically upwards with a speed that is given a 2 gm mass of Earth and radius of Earth, where m is the mass of Earth, r is the radius of Earth. Neglect the force of the object. So we are going to find out what is going to happen. So this equation, or we can say the speed with which it is projected, is our nothing but, you can say, the escape velocity. So we can say that the object is projected with a velocity which is equal to the escape velocity v, and this v will be our square root of 4, and this will be g mass of Earth and radius of Earth. Okay, so therefore from here we can draw the conclusion that the object is never going to return because of the escape velocity. Object never returns, and it is only going to follow one direction, that is upward, and moving in only one direction, which is upward. Okay. So therefore we can say that the D is going to have an option, that is moving upward means it is not going to change the direction, not going to change the direction. So we can say D is, for D, option number Q is the correct option. And let us find out about its kinetic energy. So we can say that the total energy for the, as the object is going to move further away from the Earth, the gravitational potential energy is going to increase, and the kinetic energy is going to decrease. So we know that as the object moves further away from Earth, the gravitational potential energy gravitational potential energy increases and kinetic energy decreases. So we can say that our total energy will equal to half m v square minus we have gm and m upon re. So the object asymptotically will be having a velocity that is going to approach to 0. This conclusion can be easily drawn. Okay. We can say object's velocity will asymptotically approaches 0. Okay. So means the kinetic energy continuously is going to decrease. Kinetic energy continuously decreases. So one of the options for D is R also. So therefore we can write that the finally A is matched with P, B is matched with Q and R, C is matched with P, and D is also matched with Q and R. Sorry, D is matched with Q and R. So this completes the question. Thank you.